Good afternoon. Thanks for coming. My name, again, is Sean Lane. I'm the CEO of a company called Olive. We're based in Columbus, Ohio. We're about 6 years old now as a company, have about 110 employees, and about 50% of our staff are engineers. Just to give you a little background. So I'm going to start with a little background about me. So my background is an intelligence officer, so I spent most of my career at NSA, National Security Agency. And I had that cool war guy picture. That was me in Fallujah, but really I look like this. So I was basically a software engineer. Did a lot of technical projects at NSA. It was an incredible experience. That's where I learned most of what I know about technology. I did 5 tours in Iraq and Afghanistan building technology systems. We were collecting hundreds of thousands of rows of data a second, and our job was to kind of make sense of all that data, database it, and then build software applications on the front end of that so warfighters on the battlefield could use that information to catch bad guys. For me, it was an incredible experience. I got out of NSA in 2007 and started my first software company based in Baltimore, Maryland. We built software for the intelligence community, which was a really exciting experience. After that, started to look into healthcare. Go back to that one. When I started looking at healthcare, it was because my hometown, which is in southeastern Ohio, a very rural town, was having a problem with prescription drug abuse. After I had sold my last company, I thought, hey, why don't you come back and take a look at this problem and see if there's anything you can do to solve it. So I started looking at healthcare then, and I realized that nothing was connected in healthcare. My kind of takeaway was healthcare doesn't have the internet. So no systems talk to each other. You couldn't really figure out who a person was. There was no way to connect all the data together. So I thought, what if we could build the internet of healthcare? What would that look like? So one of the interesting things about healthcare is there's all these software user interfaces. So you have the electronic medical record system, you have portals, you have lots of different software. So if you look at the screen of one of the workers in healthcare, one of the administrative employees, or one of the nurses or the doctors, they have lots of screens, lots of software screens up on their monitor. And the idea was, how can we get all these to talk to each other? And how can we do it without introducing yet another screen? So how can we build an interoperability solution without introducing another screen? So the good thing is there was a lot of advancements that have occurred in computer vision. It used to be that you had to use a lot of kind of the off-the-shelf computer vision capabilities or OCR capabilities with like Tesseract, the never-ending Tesseract 3 project. But now you can build your own convolutional neural nets relatively easily to introduce your own computer vision. So what we thought is, what if we created these CNNs around software so that we could teach a software robot to understand a software user interface? What if a software robot could look at a screen for the very first time, understand exactly what it means, understand what all the buttons do, understand what all the fields are, and really learn how to use it just like a human could? If we could do that, then we could effectively build a software robot that could work in healthcare. That's interesting. So this whole idea of scaling humans is, first, what is scaling? So scaling is this idea that you can get more out of less resources. From a human scaling perspective, we want to be able to accomplish more without scaling so many humans. In healthcare is just one example of an industry where there's a lot of humans that are working on these administrative tasks, these highly repetitive tasks, and we're using lots of humans to get that done, when the humans could be used to do better things, to do higher order things that are more sophisticated. And also it's a quality of life issue with the humans. We want them to be able to do things that they're trained to do, not have to go through the administrative slog of healthcare. Now the interesting thing about humans is that we scale through tools. If you go back in history and look at all the ways that we've scaled, these are kind of some of the events and tools that were introduced to the human race that allowed us to scale. Fire was a tool that allowed us to scale. The wheel allowed us to carry things farther distances, heavier loads. The printing press allowed us to take the knowledge out of our minds and get it out to other people at scale. The automobile allowed us to travel around the world, around the country terrestrially and around the world through the air. And then the personal computer was another moment of scale. It allowed us to have productivity beyond what we could normally do. Steve Jobs is famous for telling this story. It's a study that was done. And the study was looking at basically which animal in the animal kingdom can expend the least amount of energy but travel the farthest. And all the animals in the animal kingdom were ranked. The human was pretty far down on the list, but the condor won that test. They could go the farthest with the least amount of energy expended. However, if you gave the human a bicycle, the human could go farther than the condor with the least amount of energy. So Steve Jobs used to say the bicycle is the computer, is the bicycle of the human mind. So the way we think about it is AI is like the bicycle of the human race. So just like all those other tools, AI will be the next tool that scales humans. So that was Alan Turing. Let's get past it. So everybody knows who Alan Turing is, and everybody knows probably here in this room, this is unlike most people I talk to, understand what the Turing test is. So the idea is that how can you create something that you can't distinguish from a human? And if you take that model and you say, if humans use tools to scale, then AI should use tools too. So the good thing is, we've spent the last 30 years building these tools. So software applications are the tools that we're talking about. All the apps that exist, every software program out there, everything at your job, every different application you have from enterprise all the way to your personal mobile applications on your phone. All of these apps, AI can be trained to use. And if AI can be trained to use these tools, then AI can scale. So there's a few elements of our capability and our concept that I want to talk to you about. First is RPA. So RPA is relatively well known these days, robotic process automation. But essentially, if you've never heard of it before, it is the ability to interact with a user interface. So you can train a robot, you can build a script, if you will, to interact with that user interface, to click, to type, to enter text, to move around that UI just like a human would. So that's element one of our concept. The second element is something we call global awareness. And for us, this is really important. So in the healthcare scenario, you go to one hospital to another hospital, and they don't really know who the patient is across those two hospitals. They don't have global awareness. Global awareness really starts with the foundation of entity extraction. So imagine if you could do entity extraction and entity resolution on all the data, and then you could tie that entity to a global unique ID and be able to see that entity across many, many, many locations. Now imagine if the software robot you're building has that sense of global awareness that's shared among the different software robots. So one robot's working and crosses over a patient, knows that that patient has records in another hospital, knows that that patient has been worked on maybe two months ago, and has this sense of global awareness. And it's not only for patients, it's really for any entity. So any place, person, or thing, whether it be a drug, a diagnosis, a doctor, a patient, a location. That global awareness layer is really important. The third piece is machine intelligence. So for us, it's simply allowing the software robot to make decisions like the human has made in the past. So fortunately, in healthcare at least, when we look at all the tasks that humans have been doing for years, we have a digital record of those tasks. So we can see what a human has done 1,000,000 times over when they've encountered a denied claim, for example. And we know the different routes they've taken to satisfy that claim. So we know how to train a simple neural net. We usually use like a deep feed forward, like a very simple neural net, in order to train the human to make a decision like the humans have in the past. So imagine a process that's going forward. It starts with clicking, typing, going through the UI, understanding who the patient is, and then employing a machine learning model, a deep learning model, to make a decision just like the humans have made in the past. So that's kind of everything that constitutes our concept. So it's really those three things to us that creates this AI solution that can go in and work and take over work just like a human would do. And for us, that allows us to scale the humans, to allow the humans to reach new levels. So those things, those software robots, we call skillbots. Skillbots is kind of like the generic term for it. And it's an acronym. I came from the government, so I like acronyms. Super connected, intelligent learning bots. So what that means is super connected, meaning these software robots that you put into place to do these tasks are connected to each other, so they can talk to each other. So if you're in a hospital on the East Coast or a hospital on the West Coast, these software robots, as they're working, are connected. So they're super connected. They're connected above kind of layer 7, if you will, the application layer. They're connected on a new bot layer. We call layer 9. So the bot layer connection is important to the skill bots. The second thing is that they're intelligent, and that's where this global awareness concept comes in. They know what kind of data they're dealing with. They understand the entities. They understand the work they're doing. They have context around that. And they learn. So they have the opportunity to learn and get better over time. So if their function is to schedule a patient and the patient don't come in for the visit, they can adjust the times. They can adjust the types of scheduling in order to get a better effect for the patient to come in on time. So they have that capability to learn. And that's really what a skill bot is. Our skill bot's called Olive. That's the name of our company. So Olive uses all the crappy software. So in healthcare, a lot of that software is not very good. A lot of the solutions that we've seen other companies come up with were just new sexy user interfaces. We decided not to do that, just use all the crappy software that exists, but then teach Olive how to use it. So the thing that gets really interesting is this super connected element of the skill bots. So you're in one system, maybe on the inpatient side of a hospital, and then you're in another system working on the outpatient side of the hospital. Normally, those two systems don't talk to each other at all. But if you have a bot working on both sides, they can work the continuum of a patient between both systems. Imagine this is like two different pieces of software or two different locations of a business. The bots being able to work a full continuum of a customer, of a patient, of an administrative task across the board. And you can imagine that expands out. So now you have 3 bots all speaking to each other. They're accessing that global graph. That global graph is where the global awareness is stored. So we're using a graph database to do that, all with unique IDs for every entity in that graph. So then you can imagine that across many, many, many locations. So imagine hundreds of software robots all connected together with a global graph of identity. Imagine it across many locations being able to talk to each other and converse. So let me tell you a vignette how this all comes to reality. So this guy, he has to go to Aspen to deliver a briefcase to Mary Swanson. And he's on his way to Aspen, and he's got a chipped tooth, and he doesn't want to show up with a chipped tooth. So he stops at a dentist, but he's in Wisconsin. And he's never been to Wisconsin before. So in this world, he could text the robot, the software robot, and say, hey, I need to go to the dentist in Wisconsin. What's available? And all this, the software robots are actually logged into the practice management systems at all the dentists locally. So the software robot can log in. She can see the available schedule. She can see where there's openings, and she can say, how about 10 o'clock? So he responds, yes, 10 o'clock works for me. Then the software robot queries the other software robots and says, do you have any information on this person? And the other software robots respond with that patient's information and brings it to one spot. Now, when he walks in, he can show up to the dentist. They have all of his records. They have all of his history. He doesn't have to fill out the form. And he did his scheduling completely with the network of software robots. So that's how it all comes to life. So this company, you've probably heard of, did a really good job of organizing the world's information. That's like one of their missions. This is one of their early user interfaces. It was not on that computer. But that user interface was to be able to query a lot of publicly available data. And while Google's done a good job of organizing the world's information, they haven't organized kind of a lot of the enterprise data that exists. They haven't organized and made searchable healthcare data, for example, because it's all very guarded behind firewalls. So imagine a federated query capability with these army of robots or network of robots. Imagine you have 10,000 software robots all logged into different systems, able to respond to a federated query very, very quickly. So you could say, show me anything you have on Sean Lane, or show me anything you have on a rare disease, or congestive heart failure, or whatever that thing is you may be looking for. In this world of the federated query with the software robots, the software robot can then dip into the system and pull out the appropriate data and then organize it and bring it back. So we think, as far as scaling goes, we're kind of like in the early 80s, where most AI is thought of like the mainframe. So it is a big system that not a lot of people have access to. Big enterprises have access to it. In this crowd, I mean, most of you have learned how to access AI capabilities and use a lot of the tools that are available, but it's still very, very new to the rest of the world. So they think of it still in this big mainframe concept. But just like with the mainframe, it wasn't the mainframe that changed the world. It was the personal computer. It was this less sophisticated system, this less powerful system, this toy, this kit that everybody could get their hands on, that everybody could put in their house, in their garage, in their basement, and start building software applications, start building new pieces of new tools for humans. And that's what changed the world. It was the proliferation. It was the democratization of the capability. So we're in that phase right now with AI. We've gone from like mainframe AI where nobody has access to it to where anybody can have access to the tools. Creating a CNN, out of the box, being able to leverage all the tools that are available, whether it be TensorFlow or MXNet, any of those kind of capabilities that you can access today to create machine learning models is incredible. And we're just at that point right now, just like we were with mainframes and personal computers. I'm going to hit it's going to go like 2 slides. Yeah, see? So weird. So our vision is that if we had a platform that made it super easy for anyone to create these skill bots, anyone to create these software robots that were all connected together, then we could have thousands of humans building millions of skill bots. And if they could do that, we would build essentially a network of bots that could bring together lots of information on different enterprises, whether it be healthcare or financial services or oil and gas, manufacturing. You could actually build a software robot that contributes to this network of other bots and allow that to be able to talk to each other. So that's what we do. We create a platform that allows people to build these skill bots. We do it strictly for healthcare. We're very healthcare focused, and our tool's made specifically to work inside healthcare. But that's our vision. And that is my presentation, and I want to have some Q&A, so please ask questions. We'll start here.
How do you deal with bias across such large networks?
So a lot of the machine learning models that we're creating are still within the individual systems. So we'll look at like one health system worth of data to create the models. So we're not taking a lot of data from the other systems to build the models right now. They're all kind of self-contained inside that world. Now, if that health system has enough data to produce a model, one example is insurance cards, right? So we have reading of insurance cards is still not like the easiest thing in the world to do. So there's your off-the-shelf OCR, which does an okay job but not a perfect job. So we have some hospitals that have millions and millions of insurance cards, and we have the ground truth of what are on those cards because the humans have been basically transcribing what's on the card. So we can train a model to basically look at an insurance card and tell what's on it because of all that data that we have. We can take that model because it does apply to many different health systems, and we can use that model in other health systems, but we haven't really commingled a lot of data from different health systems, and so we don't have that problem today, but I'm certain that that's going to be something we have to address in the future. I had a question here. Yeah. So the question was about like data standardization across the systems. So my background coming from NSA is like the data are very heterogeneous in that case. There wasn't a whole lot of data standardization. So that became something that was kind of ingrained in the way that I thought about solutions from the beginning. And that's why we use the entity resolution. And essentially the graph is our data model. So in healthcare is relatively standardized. I mean, people in healthcare say it's not, but it's pretty standardized. They're using relatively standard data. A lot of the free text stuff that's in the transcriptions and the notes is, we have to apply NLP on top of that. But most of it is able to be, we can run it through NER or any extraction in order to create essentially a graph. And then that knowledge graph is what we use to bring it all together into a data model that's universal. Good. Yeah, so HIPAA is a very interesting law. So I was used to dealing with sensitive data in the past, and the Fourth Amendment was very restrictive. But the good thing about HIPAA is that in the law it says that people have access to their data. So sharing is almost mandatory. And I know most people don't think of it that way. But the challenge is you have to you can't just share the data openly. There has to be business cases and agreements, and then the ability to basically ask the patient for their permission in many cases. So that has to be part of the system. But as long as you can handle that from a business logic perspective and include the patient in the permissioning process, then that data can flow pretty regularly. So, for example, if I want to share referrals with a hospital to a doctor's office, I can share those referrals back and forth with a business agreement between the two systems. In your typical data sharing world, it's kind of like pipes turned on, and that pipe turned on both sides is hard for them to reason about because it's a free flow of information. With the bots doing it, it's very specific to a specific business case. So the bot can share just referrals for these kinds of patients to just this health system. So it's very like contract driven between the bots. So it's this network of very complicated contracts between the bots. That's how it has to happen today. Data quality instruments. I don't know that answer of what we use. We use a lot of different like ontologies and dictionaries that are built into our platform from a healthcare perspective. So we'll take the data in its kind of native format, and then we'll access. So in healthcare, you have like dictionaries like SNOMED CT and LOINC and ICD and CPT. There's all kind of dictionaries and ontologies. So we run our data through that if that workflow requires it, so that we can basically normalize it to a term or a dictionary use that's kind of standard across the system. But as far as like other data quality tools, I'm not sure. Yes. So basically, it's not at the dictionary level as much as it is what kind of function it's doing. So if it's like for coding, there's kind of data governance around that. If there's, let's see, insurance eligibility, there's one for that. Claims work is another one. So each kind of function has its own governance. Yeah, it's a good question. So let's say, for example, we processed an insurance card on a patient. We've read that before, and then we're presented with the same problem again. We get that insurance card, and there's no diffs in the card, right? And we can establish there's kind of zero diffs in the card. Then we can access kind of what has been done recently. But that's still a problem we're figuring out because it's still very localized. So there's almost like it's not in memory, but it's similar to that, to where there's a list of things that we've already accomplished and we can go back and retrieve that data, but it's still very localized to that hospital, so it's not global yet. So we still have to redo it at another location, another location, another location. That's a good question. Yeah, so that's a perfect scenario for this, right? You have to have at least some identity resolution of that patient. So ER example, let's say the patient presents with their ID or some kind of insurance card where we have a unique identifier or selector. As long as we have enough selectors for that patient, basically we hit that graph, and that graph's like a routing table. So it's going to tell you where that patient has things in other systems. So because we're extracting all those entities and all the work that we do, and we're putting it in a global graph. So if Sean Lane hits the graph, it will know where Sean Lane has records everywhere else that Olive has worked. Now, it's only where the bots exist. If the bots don't exist there, it's kind of blind to the system. But as long as they have a bot that makes it part of the network, then we're able to use those selectors to ride that graph routing table. Yeah, every hospital is kind of like buying or hiring. We say hiring Olive. So once you hire Olive, you're kind of part of that network. And then the more people who hire Olive, the bigger the network gets. So it's a matter of kind of network effect as far as that goes. If it's something that the patient needs to give their approval for, Olive has the ability to text, use the portal, or whatever communication medium to get to the patient to ask them for their permission, and then she can let that data fly. But it has to be authenticated. Yeah, so the question was like, where's the data stored? Is it globally? Is it locally? So the routing table, if you will, the net that's created in the graph is stored globally. So we know kind of transactionally where the patient's data are. That's the only thing that's stored locally. All the data itself is stored, or globally, all the data itself is stored locally in a federated manner. But inferencing specifically, if you're thinking about like the inferencing of a model, that inferencing occurs locally. And that's something that we are still like getting better at. We are, they're so excited to get the first model to take over their work that they haven't caught on that we need to start inferencing those models over time. So we're still working on that. It still happens very, very locally. We do, yeah. So, and there's a couple of different models there. We use an AWS HIPAA instance. So it's an AWS instance specifically for HIPAA. And they now have it so you can do GPU clusters inside an AWS HIPAA instance. So oftentimes we'll take their data and push it into our AWS instance. But it's like an enclave for just that system, that organization, and their data. But we've also deployed actual GPUs into their data centers if they don't want us to take it into the cloud. They want a cloudless environment, as we call it. Yeah, private. They say private, we say cloudless. We're trying to convince them. To go cloud. Yeah, so that's kind of the hard part of this is, as localized, if the network's not very big, then you just have an intranet again. And as far as adoption, like let's say, for example, there are 10 companies like us with a platform to build these software robots. And if you have 10 companies building software robots and maybe they're all connected, but they're all connected on different networks, then it doesn't matter, right? Then you still have a bunch of intranets and not the internet. So I think what will happen, and this is just kind of my vision or speculation, is that as other platforms emerge that are building bots specifically in healthcare from an industry perspective, I hope we can adopt some kind of standards. This is where we've thought about blockchain from neutrality, from a neutrality perspective, so that bots can exchange data between, our skill bots can exchange data with other skill bots, and that way you don't have that fragmented network that you're talking about. But it certainly is going to be a challenge. Right now, we're kind of like the only ones doing it, so we are that internet, but we can only grow so fast, right? So hopefully there are other players that adopt it too. So not yet. We decided to stay focused in healthcare. Like in the very beginning, I wanted to build the internet for healthcare, is what I called it. So we're super laser focused in healthcare, and because we're a startup, we're a well-funded and large startup by startup standards, but we're still a startup. So we're trying to focus our resources into one industry and own that industry. But we've certainly been very. It's been hard to kind of not go into other industries. There's been a lot of urges to go into other industries. We did kind of do one deal in DoD, so we do have a DoD version of this too. But we just couldn't pass it up, and we needed the money, so we did that. But mostly we're focused in healthcare. Not to say that there won't be others that do the exact same thing in other industries. We would certainly encourage that. But yeah, there's applicability across any enterprise, really. Level of what? Sorry. Yeah, so we're still the Olive has been in the market 2 years, less than 2 years now. So we have hundreds of Olives, not thousands. We have, I think we cover 250 hospitals, something to that effect. But yeah, it's still relatively small. We're still growing. Right now, we build the bots ourselves, but we don't want to do that. We can only build, 1,000 bots. We want to build millions, so we're trying to enable everyone to build the bots. So that's why we tried to make the platform really easy to use, so that truly anyone, if somebody wanted to in their dorm room build a business around creating a software robot for healthcare that did some administrative tasks, they could use our platform to do it. And then suddenly we have more bots out there on our network. Exactly. So we're just now launching our, like that, well, if you go to oliveai.com or olivequarterly.com, we can lead you to where our platform is. I think it's buildolives.com, takes you to our platform, and it's like free to download and use, but that's the idea, is we're trying to get as many people on the platform. Mostly like consulting companies that work in healthcare. That's kind of our first target. Other questions? Anything at all? Cool. Well, thank you for your time. Appreciate it. Have a good conference.